Sato has been one of the leading companies specialized in maritime and port works in Spain since 1927, with a remarkable business development in recent years as a technology provider in its fields of specialization. As a result of its know-how and commitment to innovation, Sato has developed, together with the Polytechnic University of Valencia, Cubipod, a groundbreaking concrete armor unit for mound breakwaters. Cubipod is designed to take advantage of the strengths of the traditional cubic block, but correcting its drawbacks by preventing self-packing and increasing friction with the filter layer. Cubipod is the most robust element in the market, and thus it can be built to any size. Unreinforced Cubipod performs high resistance to impacts and also to static and hydrodynamic forces in the breakwater. Concrete requirements are not a critical issue when using Cubipod. Both single-layer and double-layer Cubipod armors are much more stable than the armor of any other massive unit. Concrete consumption is therefore reduced. Due to its shape, Cubipod armors significantly reduce run-up and overstopping rates, thus allowing for a reduction in crest elevation. The roughness observed in Cubipod layers dissipates wave impact, significantly reducing the forces reaching the crown wall. Its protuberances, besides increasing the friction with the underlayer, avoid face-to-face arrangements. Cubipod self-relocates and armor layer porosity stays homogeneous during its service life, adapting to eventual settlements. Construction process using Cubipod is very easy. Molds are designed to optimize performance. Vertical stripping can be done 6 to 8 hours after concreting and produce up to 3 units per day. This means less molds on the worksite. Cubipod can be produced in compact lines, reducing the space needed when using lateral opening molds. No leveling slab is required. Cubipod allows very packed block yards, stacking up to 5 levels or more, depending on the ground resistance. Consequently, storage area is reduced. Quick handling and manipulation of Cubipod is performed by elementary pressure clamps directly from the crane, reducing personnel and improving safety. Transportable by track, barge or other means, bearing in mind the lower protrusion. No orientation is needed when placing Cubipods. This operation is performed with pressure clamps and positioning through GPS on the crane jib. The Cubipod shape induces random self-positioning over a pre-designed collocation grid, placing rates up to 12 units per hour. All these features result in significant economic advantages, thanks to its reduced concrete consumption, lower construction costs, or lesser quality requirements for concrete. Also, standardized construction processes reduce project deadlines. Constant porosity throughout breakwater life cycle means that no maintenance is needed. Cubipod is also a sustainable armor unit, reducing environmental, energy and carbon footprints due to its lower material consumption, and creating the appropriate conditions for marine life settlement when in use, thanks to the holes between pieces and the low run-up rates. A lower overstopping rate also enables a lower crown wall height with positive impacts in both economy and visual impact. Directly compared to cubic blocks, Cubipod presents a much higher hydraulic stability, lower run-up and overstopping rates. Its shape ensures no face-to-face arrangements, higher armor randomness and higher friction with the underlayer, where smaller rocks are needed. Compared to bulky armor units in a single layer, Cubipod has a much higher structural strength, so the unit size and armor depth is not limited, and concrete quality is not critical. Casting is easy using vertical molds. Production rates are high and handling is safer and more efficient using pressure clamps. Cubipod also allows multi-level stacking in the block yard and has an easy random placement. Cubipod, the most efficient armour unit for mount breakwaters.